So we're gonna do notes a little different than like we normally do. And so it's gonna be a flip video, but I'm trying to only go about 15 minutes because I should be back in class pretty soon. But just in case, I want to go a little bit longer in case something happens. I had to go to my daughter's school for her fun run, but I should be back around 9:15. So, mechanisms. Here we are, guys. We're getting to the information we need to know so we can start building. So, a mechanism is defined as a device that transmits movement so that the output movement is different than the input. So, when we hear some vocabulary right off the bat, output, input, input is the motion that you put in, and then the output is what happens as an effect. So, I know you have your 2 sheets of notes. We are going to be filling those in. However, if I go over something and you feel like it's important, definitely add it to the notes or write it in your GTT notebook. We are going to be gluing these in because the information that we are going to learn about today is going to be vital for the rest of the robotics course. So let's talk about the difference of the output. Well, a mechanism can change 4 things, technically 5. It can be used to change direction, speed, force, which could also be torque, or type of movement. So the output of a robot or any machine in motion of a force is in the same form. So I would definitely, in these first 2 sentences, either highlight them or write them down in your notebook. So here we go. Here's an example of a mechanism. It's a drill press. So this has 2 different types of motion. It has a rotary, which is a circular motion, and linear. So in this drill bit, you actually crank this lever. That is your input, and you're moving it in a rotary motion, which is a circular, and it causes this drill press to move up and down. That would be your output, and that is in linear. And technically, it's actually reciprocal because it goes back and forth. Also, the speed of the drill bit is going to be within a given range. If the drill is turning too fast, the drill bit could be damaged. So, accurate speed and pressure are very important. So, mechanisms can be used to help with that. And then, of course, when we talk about mechanisms, you have to think about a multiple speed bike, right? Taking your 10 speed and riding that bike up the hill. What do? Do you leave it in the same low power gear? No, you change your gears in order to get more power for the same amount of effort. We call that torque. You go up to a higher gear, which means a larger gear, so that you can get more torque out of the same amount of input. Now, when you're going on a flat surface, you shift down so that you can pedal faster and get a higher speed. So this need for change in speed or torque is a problem that is extremely common when it deals with machines, tools, robots, automobiles, airplanes. And in this activity, we're going to learn the different techniques to help us change speed and torque and even direction. All right, so the very first mechanism we're going to talk about, I'm going to make this a little bit smaller. One more. All right, that looked weird. Sorry. Is a gear train. So a gear train is a mechanism that is used to transmit rotary motion and torque. Gears transmit rotary motion through their interlocking teeth. So if you look right here, a gear train is just when you have 2 or more gears linked together. The gear train is made when they are moving, and they will move in opposite directions. So let's just say this gray one is our input. If we were to move this gear in a clockwise motion, the output would actually move in a counterclockwise motion. So right off the bat, we've changed the direction. If we would want the direction to go the same way, we would just need to add a 3rd gear to make it go in the same direction. So we're also going to be going a lot into ratios. This should be a good review from 6th grade. Gear ratios are always going to be compared to the driven gear to the drive. Again, there's some more terminology. Drive is going to be the same thing as your input, and driven is going to be the same as your output. Now, this is opposite to what we think. We would think, hey, let's put our input and then do our output. Well, when you talk about gears, you flip it, and you're going to see why that is later. So if the input drive gear completes 4 revolutions to every 1 revolution of the output driven gear, then we say the gear ratio is 4:1 or 4/1. And what that means is notice how this first one, which is our input, is smaller. So it makes sense that this input is actually going to make 4 complete revolutions to this 1 revolution of our output. So that's why we switch it. We put our output before it. Now, if you look at this picture, it talks about if you increase the speed of the drive, you're going to decrease the speed of the driven. On the flip side, if you decrease the torque of the drive, then you're going to increase the torque of the driven. So the input and output are always going to be opposite of each other. Okay, so gear ratios are determined by the number of teeth a gear has. And teeth are going to be like the little spokes. I know this picture doesn't really show it, but right here, you have your 1, 2, 3, 4, 5, 6, 7, 8. This gear we would call an 8-tooth gear. Or this gray one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if we wanted to do the gear ratio, and I was to say the gray is the input, we would do a 7:13, putting that output first. Okay? I know it's weird, but you'll get used to it. So here's some terminology. We know a force, right? You learn a force in 6th grade, and you're also going to need it again in 8th grade science. A force is a push or a pull in a straight line. Well, torque might be a little new for you. It's a push or a pull, but in a circular motion. So definitely know the difference between those. Well, gears do turn in a circular direction, and there is an inverse relationship between torque and speed, meaning completely opposite. So if a 10-speed bicycle has 10 different gears, when you're pedaling uphill, you actually want to switch to a bigger gear. This is going to give you more torque, which is a more turning force. In doing so, you're going to get less speed. Like I said, when you switch to a flat land, you're going to shift down, but you're going to be able to pedal faster and get more speed. But in doing so, you're going to have less torque. Okay, so let's look at the pictures of the 2 bicycles. Let's look at A. Again, these are our pedals. So the left gear, which is our larger gear, is going to be our input, and the right gear is going to be our output. So the gear train in which diagram provides more torque? Again, if we want more torque, that means we want less speed. And the bigger the gear is, the slower it's going to be to turn. So more torque. And some of your minds are going to completely get this and click, but mine is not that way. So when I think about these, I have to really stop, slow down, and make sure I get it right, because it can get extremely confusing. So if you're like me, don't worry about it. You'll get the hang of it. So here's my thought process if I was working this. More torque means less speed. So therefore, I want a bigger gear, which means it must be B, right? Or would it be A? So think about that. What are we measuring? Our input or our output? Well, if we're wanting a gear that has more torque, automatically we need to look at our output. So which one is bigger? Yes, A has a bigger input, but B has a bigger output. But if you look at the 2 outputs or the 2 drivens, which one's going to move faster? A is going to move faster because it's smaller. So therefore, the answer to the first question is B. Okay? And if you're still confused, it's okay. Let's do a couple more examples. So let's get to the second one. The gear train in which diagram provides more speed? Okay, well, that's the exact opposite, right? More speed means less torque, smaller gear. That must be A. And then the last one, which gear train would you use to ride uphill? So When we talked about going uphill, we said we wanted more torque, so that would be B again. And if you get confused, just rewind it, watch it again. So here we go. We need to fill out this chart, and we're going to see how torque and speed are different. So what would you fill out if you wanted more torque? So more torque would mean less speed, so therefore a larger output gear. That's what I would write. So go ahead and pause the video and do that. On the flip side, if I want more speed, that means I must have less torque, so I want a smaller output gear. Okay? So as the size of the driven gear decreases in relationship to the size of the drive, the output speed increases. That's what I just said. As the output increases, then the torque increases. So notice how that is here. If the driven gear decreases in size, the speed increases. Again, that just means smaller gear, faster speed. Larger gear, larger torque, which again inversely is slower speed. So let's fill out this chart right here. Now we're going to focus on increasing torque and speed, but we want to do a driven gear size. So driven is the output, which is kind of the way I think anyway, so we're not really changing anything. If we want more torque, then that means we want a larger driven output gear. If we want more speed, then we want a smaller driven output gear. Now, I keep saying both because I'm wanting you to make sure you understand the vocabulary interchangeably. If you prefer drive and driven or input, output, that's fine. But whichever choice I use, make sure you understand that it is the same thing. All right, let's see. Let's do this gear ratio. And then I think I should be done. So again, do not forget when we are doing gears, you have to go with the output first. So if we have an input gear that has 8 teeth and an output gear that has 40, we would write that as a 40-to-8 ratio. But just like math, you need to simplify and reduce your numbers, which would represent a 5-to-1. So what does this explanation mean? Again, don't forget that this is flipped. So here's the reason why we flip it, is for this explanation. If your gear ratio is 5-to-1, then that means that my input and drive must turn 5 times for every 1 driven gear turns. Okay? And if you stop and think about that, you're like, wait, what? But you have 40-to-8. Okay? Yes, which reduces to 5-to-1. Yes, this is my output. But doesn't it make sense if I go back and look, if my input's smaller, then it is going to move faster than the output. Okay? And so then the next one, I'll do this one with you, and then I'm going to let you go and do the rest of the sheet on your own. If we wanted to do the ratio of an input gear with 36 teeth and an output with 4, that would be a 4-to-36 ratio. Of course, it can be reduced even more to a 1-to-9 ratio. So what does that explanation look like? If the ratio is 1-to-9, that means the input gear is going to move 9 times for every 1 turn of the output gear. Again, meaning that I will have less torque or more speed because my output gear is smaller. So go ahead and fill out the gear ratio and the explanations for the other two. And then if I'm not back in time, you should have a Rube Goldberg picture like this that is at your table. And they should have the gears numbered 1, 2, 3, 4, 5, 6. You're going to go down here to this section on number 5 and number 1, 2, 3, 4, 5, 6. And then you need to talk about the purpose of that mechanism. Is it to change the speed, force, torque, direction, and then what type of movement is it? So when you look at the type of movements, they are right here above you. There's rotary, which means it moves in a complete 360-degree circle. There's oscillating, where it goes back and forth in an arc in 180 degrees. There's linear, where you go straight in only one direction. And then there's reciprocating, where you do go in a straight line, but back and forth. Okay? And if you happen to be just zooming through it and this is easy to you, and then you get to the conclusion questions, make sure that you label and actually point to the input and output of every movement in the pictures, and then tell me the type of movement that it is. All right? See you in a bit.